I hate to burst your bubble, but not all bubbles are burstable. Before we dive in, let's go ahead and talk about what bubbles actually are. Bubbles are just water, soap, and air. Now, water is a polar molecule, meaning that there's a positive side and a negative side. They join together so tightly and create really strong surface tension, meaning they do not like to separate. But then that's where soap comes in. Soap is a double-sided molecule, meaning that there's one side that likes the water. This is called hydrophilic. And then there's the other side that is hydrophobic. It does not like water. Therefore, when it gets in between the water molecules, it actually lowers the surface tension, giving a little bit of stretch and allowing it to form that bubble once air gets in the picture. And then once we have our big, beautiful bubble, it starts to lose water through evaporation, which makes it pop. But that's where our secret ingredient comes in, corn syrup, which is essentially glycerin. Glycerin slows evaporation, meaning it can hold on to that water longer, which allows it to stay wet longer and form the bubble longer. This also lessens surface tension even more, giving you a little bit more stretch and wiggle room, making it unpoppable. So let's dive in. Okay, for this experiment, you're going to need 5 things. You need water, dish soap, corn syrup or glycerin, a straw is what I'm using for a bubble wand, and a glove, whether it's a latex glove or a cotton glove. That's going to be our ticket. Let's make our unpoppable bubble. So first, our basic bubble solution, water and dish soap, or just soap. I'm going to go ahead and pour the soap into my half cup of water. This is about 2 tablespoons of dish soap. Now I'm going to stir. Now, soap and water is our original bubble solution. So normal bubble solution is just water, soap, and air. Pop. Too easy. So we're gonna add our secret ingredient. Our secret unpoppable ingredient is corn syrup, essentially glycerin. So when we add this glycerin, I have about 1 tablespoon. This is going to increase the surface tension even more. So I'm stirring it nice and slow. I don't want to create a lot of bubbles, but I do want the glycerin to get evenly distributed throughout the solution. Average bubble solution pops because the water evaporates too quickly from the bubble, making it pop. But the glycerin actually allows the water to stay longer, making it harder for it to pop. Let's see if our solution is ready. It's not. Pop, pop. Back to the drawing board. I went back to the drawing board and thought, what could be going wrong with my experiment? What is something that could be changing the outcome? And I came to a final conclusion. It must have something to do with my hands. The oil on my hands can break that surface tension barrier. So I added a glove. This glove should eliminate the oils from being an obstacle in our unpoppable bubble solution. Let's see. Give it a stir. Now, because the solution is on the straw, it's able to slip inside the bubble because the molecules basically recognize each other. So the molecules see it as one of its own. How cool is that? All because of a little glycerin changing the level of the surface tension. Let's see if we can do a bubble inside a bubble. Double bubble! That is awesome. So next time we blow a bubble, know that there's a whole world of science inside this little floating sphere.
If your students enjoyed this activity, check out the standards-aligned chemical versus physical changes video lesson at generationgenius.com.